everybody. You know, when I was a child and we had to make telephone calls, we had to go over to the talking box on the wall and crank this crank, and then an annoying woman would come online and she would basically ask us what we wanted, and we'd tell her the number we wanted to be connected to, and then she would fiddle and diddle with some wires and connect us to the party that we wanted to speak with. And during our whole conversation, she would listen to what we said, and then she would know about everybody's ailments. Tell everybody.
Hey, anyways, enough of that. So this is the little thing I picked up at the yard sale find. It's non-machine related, but I just thought it was an interesting little device, and I decided that since I'm probably going to end up trying to sell it, that maybe I'd try and do a little bit of work to it. Very minimal. I thought it was kind of interesting. The company is Century. For those of you who don't know what this is, well, I can't tell you the exact name of it either, because I'm not an antique telephone expert, but an antique telephone expert could probably tell me the proper terminology or nomenclature for this device. But I would say that telephone generator or Magneto might work. Now, the Magneto principle is a little bit different, because the Magneto principle, you've got a the way that the magnet goes past the field coil. It's kind of a different action, and it generates a very momentary high voltage, whereas this is more of like a generator, because the design of this is that as you crank it, it's supposed to put out a constant DC voltage. So anyways, so this is for a telephone, and this is for an old telephone, where back in the early days of the telephone industry, what you had to do was the telephone was on the line going to a switchboard in town, and when you wanted to make a call, what you did was you cranked this crank vigorously. That would send voltage down the line to the switchboard, and it would ring a bell at the switchboard, or a buzzer, and some kind of sounding device, and that would alert the operator that somebody was on the line, at which point she would pick up her headset and she could talk to whoever it was that was on the other end of the line, and they would say to her, hi, usually they knew who she was in small town America, and they would say, can you connect me with so and so or such and such number, and she would be sitting in front of a switchboard, which would have a panel with a whole bunch of jacks and a whole bunch of plugs and cords. And what she did was she took the corresponding cord and plugged it into the jack that would make the connection, so that now that line going to the house you want to talk to is connected to your line. And I was kind of joking about it before, but the reality is that the whole time you were on the line with the party you wanted to speak to, she was also on the line, and proper etiquette would have been not to listen in. But I think back in those days, a lot of gossip was handled by these women. Who knows how many tips and scoops and deals people get over the years because they heard about them through their local telephone lady. Anyways, this is kind of interesting that this is chromed in the front here. The chrome's in really bad shape. And I thought, wow, boy, the chrome's really in bad shape on the back side. But then it occurred to me, I don't think this was ever chromed on the back. So this company, I guess for economy reasons, I think they only chrome the front. So I'm assuming that when you opened up the telephone box to service it, that this would be facing out with the Century name and chromed, as opposed to this side, which has the Century name but is not chromed. This is called a 5-bar because it's got these 5-bar magnets around this spinning, I think we call this an armature, I'm not sure, and depending on the condition that's in, it might be a lump of useless copper at this point, we don't know yet. But the first thing I noticed about it when I picked it up and cranked it was it makes this horrible noise. And I was looking at it more closely, and I realized that up here on the top of where this drive gear is, there's a hole. I already cleaned out the dirt that was in it. There's a little hole there. And if I put oil in that hole, it's going to lubricate this point right here. And not only that, but below that, there's almost looks like a tube cast into this little side plate. And that goes down to the little bearing or bushing that's in here for this side. So put oil in there, it'll oil both of these. Same thing on this side. We've got one on this side. This one actually has a little piece of wicking in it. I thought it was dirt, and then I pulled it out and realized, no, that's a little bit of felt packing or wicking. Same idea. Oil's going to go in here, down through this little channel back here and into here. So what I want to do at this point is I want to get my little machine oiler and put some oil in there. So for this little application today, I'm going to use the good old 3-in-1 oil. Looks like I'm going to have some skill there, son. Alright, right now that's topped off. Let's see if when I turn this, if it goes down any. The level's not dropping. If there was an oil groove in the shaft there, which I would expect, then I would expect that level. Oh no, there it goes. Now it's going down. Alright. So it's going to take a little bit for that to work its way around this bushing and then down that tube into the other side. Meanwhile, while I'm waiting for that, I'll put some in on this side. This one's flowing a lot more quickly, even with the felt in it. That's probably the felt is very dry and it's wicking up that oil. Of course, I'm assuming that all that noise is from these bushings or bearings. If I can localize the sound. It might be, maybe this is rubbing. Hard to tell. I wish I could get some oil right into these bearings right away. It does seem like it's getting a little better. Definitely getting smoother to operate. Alright, I don't want to get oil on this thing down here. This armature or whatever it is, but I do want to see if I can clean no, that's not rubbing. That's not the problem. Oh, well, yeah, you know what, it could be. Yeah, unfortunately, it might be rubbing because well, there's a little tiny screw there, but that actually just stuck to the magnet. That's improving. If I go slow, it stops making a noise now. Oh, there we go. Alright, so that should be, let's see. If this is the front. Alright, well, I'm not going to go through the trouble of taking this apart, cleaning all of these parts, and putting it back together. I'm going to leave that for the telephone restoration person who might want to buy this and leave it to their skilled hands. So, from what I can see here on this thing, these two screws right here must be the terminals that the wires hook onto. And I can see that there's insulating material here to isolate this post from this post, which makes sense because if this wasn't in here it'd be a dead short. But I can also see that this post behind here goes to this little leaf spring or contact that through spring tension is pushing on the end of the pin that this armature basically is assembly is attached to. This outer post goes to this leaf spring, which is sitting out here in the middle of nowhere doing nothing. So obvious to me that this should touch this. Now the question is, yeah, okay. So there's actually some sort of a device in there down the end, some sort of mechanism that doesn't allow this to come in contact with this leaf spring on the end here, or this contact, until you get this up to a certain amount of speed. So you'll see that when you start cranking it, well, actually, I guess as soon as you start cranking it, it goes out. But my point is, they don't want that in contact with the line. They don't want that in the circuit, so to speak, when it's not being cranked. So that's interesting. Clean that up a little bit. But right now, even when it's cranking, it's not poking out and touching that contact. So there's something awry there. So if I turn that in just a little bit now, you can see when I crank that, now it's doing what it should do. Alright, so let's have some fun. Let's see what we can get out of this thing for electricity, if anything. You know, back when I was a boy, when we put a little piece of wire on something like that, we called it a pigtail. I don't know what you whippersnappers call it today. Alright, so, got myself a couple of little leads here. Going to use that to attach my high sensitivity, high precision, ultimate Radio Shack pocket meter. But this, I found this in the toolbox fine the other day, and it actually works. Now I'm pretty sure this thing puts out DC. So let's see, that's voltage DC, and this is auto ranging. So right now it's showing that this thing's putting out 13 millivolts. Not. Well, it's all over the place, but it's just millivolts. I think I just turned that the wrong way, didn't I? I did. Overload? Wait a minute. It's supposed to be auto ranging, for crying out loud. Well, ain't that a kick in the head? Oh, there it is. Okay. So just keep cranking. Eventually the auto ranging feature will wake up. I can't get a reading with that. Oh, hold on. What? Yeah, I fed the hog. Alright. We don't really have a hog. We have a cat that I call a hog because she does nothing but pester me when I get up in the morning, and then when I feed her, she scarfs it all down like we're starving her. Yet the vet says she could lose a few pounds. But you know. Alright, so we're done playing around with the inferior little meter here. We got my tried and true Fluke number 12 auto ranging voltmeter. This meter is a great meter, and I've had this for quite a few years. I think I actually bought another one of these that's like new in the box, and I've got it tucked away just so in case someday this finally does fail me, I can have another one, because I just really like this meter. Anyways, this is a fully auto ranging meter, and it's got much quicker response time than the other meter, but it's got another feature that I'll show you in a moment. But first, just for giggles, let's try this again. So we can see it's putting something out, but it's so erratic, I can't tell what. And I also notice now that it's had some time to sit. If I crank it fast enough, that still makes that horrible noise. But alright, so now let me show you about this other feature this meter has. This has a min-max feature. So basically, if I hit this button, and what it'll do, sometimes these buttons are a little flaky on this thing. I have to take it apart and clean it from time to time. Anyways, alright, so now I've activated the min-max feature, and so what the meter's actually doing right now is it's kind of like recording an event. And what it's doing is it's going to record the minimum voltage sensed, which is going to be 0 because it's not cranking, and then the max voltage reached at any point during the duration of the cranking, right? So let's see, I'm going to go, yeah, alright. Alright, so now what you do is you press this button again, and that's showing me the minimum voltage reached was 0.016. And then, alright, so the max, Oh, I didn't have the range set correctly, so it says overload. Darn it. Alright, I'm going to reset it and do it again. Alright, so... Okay, so I've reset the range on the meter. So now I'm going to re-engage this min-max feature. Again, I'm thinking it's probably this way. Well, that only seems to be throwing out a volt. Let me see if... Ah, stupid leads touched. I actually seen sparking. No wonder why I'm getting nothing. Max was 0.08. Yeah, I don't think so. I saw that higher than that before. Yeah, let's try this again. $14 volts. Okay, that sounds right. Let's get a light bulb. Alright, so this is pretty interesting. I just kind of rigged up a haphazardly rigged up a bulb, and I was just had this resting on this gently, and I was having real trouble turning this, and then the wire fell off because I just barely had it touching on there, and all of a sudden it got easy to turn. So it's real easy to turn when there's no load on it, and then what happens is when I put a load on it, I get it spinning, which actually, if I short circuit this, I can demonstrate it. It's not touching. See how hard it is for me to turn this when there's a load on it? Well, guys, I did a little research online about these things and found out that, well, in fact, the one of the first mistakes I made was assuming that this had DC output. Apparently it's AC. It actually generates alternating current. Couldn't figure out why I wasn't getting much. And then I noticed that when I would check my min-max, I would have like 15 volts DC positive, and then the min would be negative 15 volts. And what it was actually looking at was it was looking at the AC from peak to peak, I guess. So that would have been about 30 volts AC that I had done at some point. So I flipped it over to AC, and sure enough now, when I put it over to AC, you know, spin it moderately, I'm getting about 50 volts. If I get a little more vigorous, I can get up to 70 volts AC. Now that's no load. The other thing I learned was that apparently it's quite normal for it to act the way it was acting when I hooked the bulb up here and tried to crank it. It got all squirrely on me, like that. And it turns out that what's going on there is it's actually the load that's causing that. So the no load circuit's working fine. The problem is the cold filament in this light bulb has very low resistance, so this circuit looks almost like a short to the generator. So until it actually starts to get the light lighting, it's not going to want to really do anything. I'm getting a little bit of sparking, that's about it. So I'm kind of surprised. I don't know why this can't seem to handle the job of lighting this bulb. This should just be a, I don't know, I just randomly found this bulb in my junk, but it sure looks like that should be like a 12-volt bulb. Alright, so I went and got myself a little panel light that I have, and this panel light has a, it's probably for a higher voltage. I'll see if I can figure out what voltage that light's supposed to be for in a minute. So that means that the cold resistance of the filament is going to be higher, and that's apparently the key here. So now I can see it. Works pretty good. Now apparently, years ago when people started throwing these phones out, and they were, you know, all over the place. They weren't considered antiques at that point yet. What happened was people were tearing these things out of phones, and I guess at some point somebody figured out an idea of how to use this thing to go fishing. So that's one of the things I learned today that I did not know, is that this apparently was a device that was repurposed to electrocute fish in ponds. How do you like that? Alright. Well, anyways, I'd say that this thing works.